Career advancement is considered a right in many physical workplaces, but it is not yet in place in online labor markets. Up until now, most crowdsourcing research has catered to platforms with the goal of ensuring high worker performance, such as quality and cost. However, investing only in worker-centric needs like skill improvement often conflicts with short-term platform-centric needs, such as task throughput. The study of human factors in crowdsourcing is a recent trend with various contributions that account for motivation, mental stress, learning, fatigue, and boredom. In this study, we revisit task assignment and examine the impact of learning strategies on worker performance and skill improvement. The figure shows typical crowdsourcing settings. Here, we assume we need to crowdsource a set of tasks of varying difficulty levels, and each task receives 3 contributions. Some tasks have already been completed by some workers. Our problem is that, given a worker and set of uncompleted tasks, which sequence of K tasks will maximize workers' learning potential? In other words, our challenges are how to choose an appropriate batch of K tasks, how to order the chosen K tasks appropriately, how to reconcile worker-centric and platform-centric goals. To address these challenges, we formalized learning potential of a worker grounded in learning theories. Zone of proximal flow, ZPF, shown on the left, is the underlying theory that integrates Vygotsky's zone of proximal development and Csikszentmihalyi's flow theory. ZPD introduces learnable zone where students can learn assisted by a teacher or higher skilled peer. Flow theory illuminates the relationship between worker skill and task challenge. In ZPF, to improve skills indicated by dotted line, the tasks should be either in the flow zone or in the learnable zone. Since learnable zone is a bit more challenging for workers, there should be some scaffolding to help workers complete tasks. This is the reason for adapting collaborative tasks in addition to individual tasks. For the task assignment, previous work found that both task ordering and task types impact quality and completion time. So we devised learning strategies based on 2 ideas: task ordering in 4 patterns and interleaving individual and collaborative tasks. Let me define the problem. Our problem is, given a worker, W, and the batches of tasks completed by W up to iteration I. Find a batch B of at most K tasks to assign to worker W at iteration I plus 1, such that maximizes the learning potential. Optimal difficulty of tasks would be from flow zone and learnable zone. This task assignment process can be solved as a knapsack problem, and top K search can be computed linearly with the number of tasks. In this video, we'd like to skip the detailed formalization and solution algorithms, which are described in section 3 and 4 of the paper. Let's move on to the experiment part. We conducted experiments to verify the impact of learning strategies on skill improvement and their performance in terms of quality and throughput. These are based on actual task deployments in Amazon Mechanical Turk. Specifically, we studied the impact of learning strategies applied to individual tasks of bird image classification in Experiment 1. In Experiment 2, we further examined the workers' learning and performance in a series of interleaved collaborative tasks and individual tasks of text editing tasks. Scripts, datasets, and worksheets used in the experiment are available on GitHub. The task is simply to identify the specified blackbird given a pair of two-bird images. First, a worker takes the pre-assessment test. Next, a worker is assigned to a treatment group and takes a corresponding treatment test. After completing the treatment test, the worker takes the post-assessment test, which is similar to the pre-test but with different questions. We conducted two variants of this experiment, one with 12 tasks and another with 120 tasks. Since completing a large number of tasks may lead to a drop in performance, and we wanted to see if the number of tasks would affect the learning improvement and workers' performance. More detail may be found in section 5.1 of the paper. We observed that all treatments are effective in helping workers improve their skill. In particular, alternate yielded the highest average skill improvement in both 12 task and 120 task experiments. We further analyzed workers' skill improvement based on their original skill level. Based on their scores in the pretest, we classified workers into novice, intermediate, and expert. We can see that the alternate is the best strategy for both novice and intermediate workers, while there is a ceiling effect for expert workers. For experiment 2, we asked crowd workers to correct spelling and grammar errors of English. In the collaborative version, they can see answer of higher skilled workers and have the option to simply edit the existing answer. We asked workers to take a pre-assessment test to measure their English skills, and based on the test results, workers are classified as novice intermediate or expert. Novice intermediate workers then work using either the cities only strategy or the interleave strategy. Lastly, novice intermediate workers take a post-test. As a result, skill improvement is significantly higher in the interleaved case compared to the cities-only case. The higher skill improvement in the interleaved case may be attributed to the fact that individual tasks are similar to cities, which may have contributed to the learning of the worker. Moreover, in the case of cities only, since there are already answers from expert workers, the novice intermediate workers may have become under-challenged, resulting in a lower skill improvement. Throughput is also observed to be higher in the interleaved case. We can conjecture that as skills improve, workers become more proficient and faster. To conclude, we devised iterative task assignment and completion approach that implements strategies grounded in learning theories. Our experiment results showed that optimizing task assignment toward workers' learning has a positive effect on skill improvement, task throughput, and quality in image classification and text editing tasks. Specifically, alternating task difficulties achieved the best balance between skill improvement and task performance, and interleaving collaborative task and individual task yielded higher skill improvement and throughput than collaborative task alone. Our results are expected to be beneficial for citizen sciences, where we often see long-term commitment of workers. While our experiments focus on image classification and text editing tasks, they might be applicable to some of the tasks in Bloom's knowledge and comprehension classes, such as labeling, counting, transcription, and spelling and grammar tasks, because they have a ground truth where workers can improve their skills by completing individual tasks or learn from each other in collaborative tasks. Thank you for listening.